In this video, we will be looking at how to find the volume and surface area of three-dimensional composite shapes. So first of all, a composite shape is just made up of multiple shapes stuck together. So you could have prisms and pyramids, cones and spheres, shapes cut in half. So to find the volume, you'll just find the individual volume of however many shapes you have and then add them up. For surface area, however, sometimes you might use an actual formula, sometimes you use pieces of the formula, sometimes you just look at the various surfaces you see and add up their areas. So imagine surface area as if you're about to paint that shape. What surfaces are receiving the paint? Some of them are hidden, and we do not want to take their area into consideration. So let's start off with our first composite shape, where we have a cone and half a sphere. And let's begin with volume. Let's start with our first shape. We have a cone, it's a full cone, and if we look at our formula sheet, the volume of a cone is pi r squared h divided by 3. I know that the radius is 6, the height is 15, and the 16.2 is actually the slant height, which we don't need for the volume. So we have pi, and then instead of the radius, we'll put 6 squared. Instead of the height, we'll put 15 all over 3, and then we can go to our calculator to get our volume. And the volume is 565.5 inches cubed for the cone. So there's that. Then we also have our sphere, but it's just half a sphere. So volume sphere. The volume of a regular sphere is 4 pi r cubed divided by 3, but because it's only half of that shape, we're going to divide that answer by 2 at the end. So the radius is actually a shared dimension between the cone and the sphere, so it is 6 again. So we'll do 4 pi times 6 cubed divided by 3, and once we get that, we'll divide it by 2. So the actual volume of the sphere is 904.8 for the whole sphere, but when we cut that in half, we'll get 452.4 inches cubed. So now we can take the two individual volumes and add them up. So volume total is going to be the 565.5 plus the 452.4, and that gives us 1017.9 inches cubed for the total volume. All right, on to the surface area. So for surface area, we can't just use the typical full formula for the cone and formula for the sphere. We have to think about it a little bit more carefully. So for the surface area of a cone, the regular full formula is pi r squared plus pi rs. But when we look at the cone, that circle on the bottom, it's not exposed to the air. It's not going to get painted. So we also know that the area of a circle is pi r squared, so this part does not apply to our surface area. It is just the pi rs, which represents that pointy cone shape part. So we have to be selective here. You can't just find the full surface area. So we have pi, the radius is 6, and the slant is 16.2. And when we multiply those, we get approximately 305.4 inches squared, because it's surface area. Now for the surface area for the sphere, the surface area of a sphere is just that circular portion. We only have half of it, so we will use our regular 4 pi r squared formula, but we'll divide it by 2 at the end. And once again, our radius is 6, so we'll plug that into the formula. And when we put that into our calculator, we get 452.4 for the entire surface area of a sphere with a radius of 6, but when we cut that in half, we get approximately 226.2 inches squared. And then we can add up that lateral surface of the cone with the half sphere to get the total. So when you're dealing with those circular shapes, like cones, spheres, even cylinders, you are going and relying on that formula that's given to you, but sometimes you might have to be a little bit selective. So for our surface area, when we add them up, we get 531.6 inches squared. And there we have it. Let's try another one. So in this next shape, we have a rectangular prism on the bottom, which is actually a cube because all three sides are the same. And then we have a rectangular based pyramid, or a square based pyramid on top. So let's start with volume, because volume, we're just going to rely on our formulas. So I'm just going to label these. One's a prism, one's a pyramid, so I'll just label it like that. So for the pyramid, because that's what's on top, the formula is, if we look at our formula sheet, length times width times height divided by 3. So if we look at our formula here, sometimes we do have to take dimensions from one shape and bring them up. So the 13 feet right here is also 13 feet here. The 13 feet here is also up here. So now I can see that my length and width are 13 feet. The actual height of the pyramid is 13 feet. Please note that the 14.5 is the height of the triangular face, so it's the slant height, which does not apply to volume. So we're going to have 13 times 13 times 13, all divided by 3. And when we plug that into our calculator, we get 732.3 feet cubed. So that is our volume of the pyramid. The volume of the prism is even better, because of a prism, a rectangular prism, is length times width times height. The length is 13, the width is 13, and the height is also 13. Because it is a cube. And when we multiply those, we get 2,197 feet cubed. And now we can add the volume of the pyramid with the volume of the prism to get our total. So nothing too fancy for the volume. You just have to select the correct formula, and you can just match your shapes, and then you add them together. So our total volume is 2,929.3 feet cubed. Okay, let's move on to surface area. And we'll start with the pyramid. Now, if you look at the pyramid, you have 4 sides exposed to the air that would get painted, and it's the 4 triangular faces. This base square or rectangle is not exposed, so we are not painting it. We're just dealing with 4 triangles. And the formula for the area of a triangle is base times height divided by 2. Now, sometimes with a rectangular prism, you have 2 types of triangles to find the area of. But if we look at these sets of triangles, they all have a base of 13, and they all have a height of 14.5, which means we're just doing the formula once, and because we have 4 identical surfaces, we'll multiply it by 4 at the end. So our base is the 13, and the height of the triangle is the 14.5. So 13 times 14.5 divided by 2, which will then get quadrupled. So the area of one triangular face is 94.25. And when we multiply that by 4, we get 377 feet squared. So I didn't use a fancy formula for the surface area of a pyramid. I saw I had 4 triangular faces, so I found the area of those. Now for the surface area of the prism. Typically a rectangular prism has 6 rectangles, but the top surface here is not exposed to the air. So I really just have the 4 surfaces going around and then the base. So I have 5 rectangles. Now, sometimes they would be different dimensions, but in this case, they're all 13 by 13, which means I can do length times width one time, and because all 5 surfaces are the same, I'm lucky and I can just multiply it by 5. That doesn't always happen, but in this case, it does because it was a cube. So 13 times 13 is 169. So one surface has an area of 169. And when we multiply that by 5, we get 845 feet squared. Now we can add those up for our total. So the prism was made up of 5 squares, the pyramid, 4 triangles. And when we add these numbers up, we have a total surface area of 1,222 feet squared. And there we are. The next one, we have a half cylinder sitting on top of a prism. So let's start with volume. Volume is the quicker one. And I'm just going to put my volume calculations down here. So we'll start with the cylinder. Now the volume of a cylinder is pi r squared h, but I do have half of a cylinder, so we are going to cut that in half. So pi. Now what's the radius? We know that this side here is 7, which means the length of this is 7 as well. But the radius is half, and half of 7 is 3.5 centimeters for the radius. The height would be this length here, which is 9 centimeters. So we have pi times 3.5 squared times the 9, which will get divided by 2 at the end. So when we do the volume of a full cylinder, we get 346.4. And when we cut that in half, we get 173.2 centimeters cubed for the half cylinder. Next, we go to the volume of the prism, which we already know is length times width times height. The length, let's say 7, the width is 9, the height is 3. So 7 times 9 times 3, which is 189 centimeters cubed. And then we can add these up quickly. 173.2 plus 189 to get 362.2 centimeters cubed for the volume. So again, just our regular volume formulas. One of them we had to divide by 2 because it was half the shape. And then off we went to add them up. Now, surface area may be a little trickier. So let's check that one out. So the surface area for the cylinder. Let's start with the typical formula that we use. It's 2 pi r squared plus 2 pi r h. But what do we have? This circle is now cut in half, so that surface area is half. Same with the back one. This lateral surface, half of it's missing. So all we have to do, take our good old surface area and divide it in half at the end. And then you're good. So we have 2 pi 3.5 squared plus 2 pi 3.5 times 9. And all of that will get cut in half. So let's see what we get. So the total surface area is 274.9. And when we cut that in half, we get 137.5 centimeters squared. Okay, let's move on to the prism. So we're not lucky, we don't have a nice cube, but we are just going to use our length times width formula for however many faces we have. It is going to be a little bit visual. So to start off with, let's do the front face, which is 7 centimeters by the 3 centimeters. This face is the exact same one as the back. So I will do 7 times 3, and then I'm going to double it because I have 2 of those surfaces. Then I have the sides, which are 9 by 3. And I have the exact same rectangle on the back as well. So I'll do plus 9 times 3, so there's the length times width. And I'm going to multiply it by 2 because I have 2 of those surfaces. And then finally, we also have the base down here, which is 7 by 9. But I only have 1 of those because the top is attached to the cylinder, so we don't see it. So I will do the multiplication individually here. So 7 times 3 times 2 is 42. 9 times 3 times 2 is 54. And 7 times 9 is 63 for all 5 of those surfaces. So the times 2 here is me just finding 2 of those rectangles. And when we add those up, the 42 plus the 54 plus the 63, we get 159 centimeters squared for all 5 rectangles. And now we can add up the half cylinder with the 5 rectangles to get a total of 296.5 centimeters squared. So this one required a little bit more work, specifically with the prism, because we had 3 different types of rectangles. All right, our last one. Let's start with the volume. So for the volume, we can start with the triangular prism on the bottom, or on the top, and I'll just put triangle here. So the volume of a triangular prism is base length height divided by 2. Our base is 12. The L, which is the height of the actual triangle, is 9. And the height of the prism is this length here, which we can take from the bottom, and it's 4 inches. So 12 times 9 times 4, all divided by 2, is 216 inches cubed. Then we have the volume of the rectangular prism, so I'll just put a rectangle here. That's just going to be length times width times height. And the length is 16, the width is 4, the height is 6. We are just multiplying those 3 numbers to get a volume of 384 inches cubed. And we can add those up for the total. So 216 from the triangular prism, 384 from the rectangular prism, for a total of 600 inches cubed. So nothing fancy again for the volume. The surface area, we will have a little tweak to it. So let's start with the triangular prism. Now the triangular prism is made up of 2 triangles, one on the front and back, and then these 2 rectangles on the sides. So I'm just going to split it up in 2 calculations. So area triangle, we know is base times height divided by 2, but we have 2 of them. So our base is still 12. The height of that actual triangle is the 9. So 12 times 9 divided by 2 is 54. And when we double it, that's 108 inches squared. So those are the 2 triangular faces. The area of the 2 rectangles we have, they are identical. The dimensions are the 4 inches here and the 11 inches here. That would be the length and the width. So we're going to do length times width and double it. So 11 times 4 doubled. 11 times 4 is 44. So that's one of the rectangles. Doubled is 88 inches squared. So the 108 for the triangles, the 88 for the rectangles, and now let's go to the rectangular prism. So for the rectangular prism, we do have quite a few rectangles. There is a little fancy trick to this top one because the top one is not fully exposed. So I'm going to leave that one for the end. I'm just going to do the 5 rectangles that are a little easier to see. So let's see. The front is 16 by 6. But I have 2 of them because there's one on the back as well. So I'm going to double that. The sides are 4 by 6. And again, I will multiply that by 2 because there's one on the left side as well. And the base is 16 by 4. And I only have one of those because the top one has a shape sitting on top of it. So I'm going to deal with that at the end. So 16 times 6 times 2 is 192. 4 times 6 times 2 is 48. And 16 times 4 is 64. And we can add those up to get 304 inches squared. Now for the top, so I'm just going to write area top. The dimensions of that rectangle, they are 16 by 4. But we have this rectangular piece sitting on top of it, so that part is not exposed to the air, so I have to subtract it. And the dimensions of that rectangle, they're 12 by 4. This by this. So I have to do a little bit of subtraction here. So this one's a little trickier. We have to visualize it a little better. So 16 times 4 is 64. 12 times 4 is 48. When we subtract them, we get 16 inches squared. Okay, now we're ready for our surface area total. We have the 108 from the 2 triangles. We have the 88 from the 2 rectangles on the triangular prism. We have the 304 from 5 of the rectangles and the 16 of those 2 slivers that are left on top of the rectangular prism. And when we add those up, we get 516 inches squared. This one is the trickiest because one of the faces is not fully covered and it's a little trickier to figure out. But we are just using our basic triangle and rectangle area formulas. So it is a visual problem. Look at your shape carefully. Imagine you are painting it for surface area. And for volume, just figure out your formulas, plug your numbers in, and then add them up.